receiver pairing. Okay, so you heard something about technical basic parameters and information. You got an overview of our standard product range with some basic informations inside. And in the last part, I will give you a description, or I will present you the handling of especially the senders and the receiver. Because how can they work together and how can they fit together? Okay, our packed receiver is the receiver on the one side with the different mounting options or the different versions, and the receiver has integrated our receiver stamp. This is the heart of the receiver. And the receiver stamps get the information from the senders, from the air, from the RF channels, and work it out and give it out to the interfaces. So remember the structure of our RF protocol. In the RF protocol is described the language between the sender and the receiver. And after the preamble, which is the introduction sequence and the knocking, yes, and after the sync word, which says, hey, now the data starts, comes the real data which are necessary between sender and receiver. And the data consists of two parts. One part is the so-called unique ID, and the other parts are the switch status. The unique ID is an absolutely unique identifier. Every switch we're producing get an absolute unique identifier in the production. So we started with the number 1, and the second got the number 2, and meanwhile, I don't know, we are number 3,000 or so, I don't know, all the engineering samples we made. But when we start in production, every sender gets a unique ID. And the unique ID data is 32 bits, 4 bytes. And this means we have the possibility to program, I think, 14 billion unique IDs. It's a lot of unique IDs we can produce. And when it's over in 10 years, maybe, hopefully, then we start with number 1 again. No, I don't know. Nobody thinks about it. What we do when the 14 billion unique IDs are over. Okay, then we create a new ZF telegram with a 5-byte unique ID. Okay, and this unique ID is important because with the unique ID, the receiver stores the, let's call it behavior, or stores the identification of the switch. So he said with the unique ID, for example, the light switch beside, near the door is the unique ID number 17. And then when the receiver gets the signal from the sender 17, he knows, oh, this is the sender near the door. And when I get the information he is pressed, I send it over the interface bus to my host and say, sender 17, send me a switch signal. And then my host can say, okay, when I get a switch signal or a press signal from sender 17, I switch the light on in the living room. And this is the reason for why we need a unique ID, to identify every switch in our system. And the data itself is only 1 bit, press or release. So on that, the receiver knows what he should do with the unique ID. Should he transmit it to an output, or should he switch on the light, or should he leave off because this is not a paired sender to me? It's necessary that we make a pairing procedure of every sender in the system to the receiver. this pairing procedure means that I say to the receiver, hey, I am the sender number 17, and when I send a switch signal to you, you have to react. And for this, we need a so-called pairing procedure. And in this pairing procedure, the sender is learned to the receiver, because the receiver gets all information in the air from every sender which is around him. But he has to decide, is this a receiver for me? It's important for me or not? And if not, he has to leave it out. If yes, he has to do something. So we need a pairing procedure. And a pairing procedure is always the same steps. We activate the so-called pairing mode, then we learn the sender to the receiver, then we deactivate the pairing mode. And the activation of the pairing mode, we had different possibilities. The easiest way is to put a switch on the receiver, and when I press the switch, I activate the pairing mode. And why it is so easy, we call it easy mode. And this easy mode means pairing by push button. We will see it later how it works. But what is when I put in my receiver behind a wall, or I put my receiver in the ceiling, and I can't go there and press a button, or the effort to go there is very high because I have to screw up the ceiling or I have to screw up my wall? Then I need a possibility to activate the pairing mode on the receiver, but not touching the receiver. And we say, okay, let's call it integration mode because the receiver is integrated in behind a wall or in the ceiling. And then we say, okay, we have, for example, a USB stick, and we put this USB stick on our computer, and then we send a special pairing signal over this receiver to our receiver and say, hey receiver, you should go to pairing mode. And so it would be possible to activate the pairing mode on the receiver without touching it, an integration mode. But this integration mode is planned, it's not currently implemented. But we prepared it, we considered it in our design, and we could implement it in a later step. So if you are in discussion with a customer, and the customer said, I have a project, but the receiver isn't available later, then you can say, okay, there would be a possibility of a so-called integration mode, and then we have to discuss with the customer the special use case, the special requirement, and then we can create or design it in a later step without changing hardware. It's only a software development. And another step could also be if a customer has an application with 100 senders and 20 receivers, then easy mode and integration mode is much more effort for him. He said he wants to configure it on his PC, and he wants to configure this sender to this receiver and this, then it would be also possible. Not yet, but it's considered in the design, and it would be possible in a later step. So it's only for you. Easy mode is implemented, is currently working. Integration or comfort mode would be possible. If you are in discussion with the customer and he says, I have this use case, then you can say it would be possible, but not yet and not in 2 months, but we have to do engineering effort, but it could be. Okay, let's go back to the easy mode, the very easiest way to pair a receiver or a sender to the receiver. On slide 6, the first step is you have to activate the pairing mode on your receiver. And activation of the pairing mode means you have to press the so-called pairing button on the receiver, it's the right one, for at least 2 seconds. So press it with a pencil, It's the best way with a pencil. Put on the pairing button, at least 2 seconds, and then the receiver switches into pairing mode. The LED flashes and you can see, oh yes, the receiver is now in the pairing mode. How it works and how the LED flashes is all described in the receiver manual. It's very, very good described in the receiver manual. So, and when the receiver is in pairing mode, then you press your switch you want to learn on the receiver. Or you press 2 switches or 3 switches, or now the question, at maximum 32 senders. Why 32 senders? We decided to limit it to 32 senders because when we have a system where many senders are in the systems, and for example 100 senders would be paired to 1 receiver, the receiver takes a little time to work out the received signal. It takes a short time, milliseconds, but it takes time. And in this time, the receiver is not able to receive another signal. It's a so-called latence time, a waiting time. And when you have 100 senders, it could be that one sender sends a signal, the receiver gets the signals, working out this signal, and in this time, in very short time, comes another signal from the sender, but the receiver cannot receive this signal, the signal lost. This is a risk. It's absolutely normal risk. A solution for customers would be, okay, then you say you have to install 2 receivers or 3 receivers, that you have more than 1. Then the risk is increased. But it makes no sense to learn 100 senders to 1 receiver because it could be problems. And this is the reason for we limit it to 32. Physically, it would be possible 246. It's absolutely maximum, depending on the RF chip. This is absolutely maximum, but we limited it to this 32. Okay, let's go back. So you can press the sender or 2 senders or 3 or 4 or maximum 32. And in this time, all the senders you press or learn to the receiver. And when you are ready, you press the push button again, the pairing button. Then the pairing mode is over and the receiver switches back to normal mode, operating mode. Note, when you switch the receiver in pairing mode, then he gets all the signals from all senders and all the senders in the surroundings are paired. So you have to make sure that only the senders are paired or pressed which you want to learn. If in another room is another guy and want to pair another receiver, then it would be a problem, because you're pairing all your senders from the other room to your receiver. And this is the reason why we plan, for example, a comfort mode. So imagine you have a big manufacturing hall with different tool machines, and in every machine 10 senders and 1 receiver is installed. And the machines are working all over the time, 24 hours per day. And now the system engineer goes to 1 machine and has to change 1 sender and 1 receiver. But the other machines are working around. So it's not possible. When he put the receiver in pairing mode and on the other machine senders were operated, and he collected all these senders to his receiver. So it wouldn't be possible. He cannot. He have to stop all machines, has to say complete manufacturing stop. I have to learn 1 sender to my receiver. It's impossible. And this is the reason why we plan a so-called comfort mode. So he could do it on a PC and all the other machines can work. So that's the reason for a comfort mode. Okay. Okay, so that's the way. You press the pairing button on the receiver, bring the receiver in pairing mode, press the sender is learned, is paired, press the pairing button again, the receiver is switched back to operating mode. And now the receiver reacts to this paired sender. He collected all the other RF signals in the air, but he only do something when he get this signal. All the other signals he lost, or he keeps away. Okay, why it's so important and why I described it so detailed. So now we are coming to the RF stamp. So, and the RF stamp is the RF heart of the receiver. And for the RF stamp, there is the same situation as for the packed receiver. You need to pair senders to the RF stamp. And therefore, you have to switch the RF stamp into pairing mode. But where is the button on the RF stamp? And where is the LED, which flashes? There is no button, there is no LED on the RF stamp. So we have a problem. How can we switch the RF stamp into pairing mode? Because the RF stamp is only a little PCB and has on this side different soldering pads which are for communication with the power board here. And over this soldering pads here, the communication, the power supply, all these informations go from RF stamp to power board. And also the information of pairing button, pairing start, pairing stop, LEDs, which are here, all these or switching the outputs, switching the interfaces, all these informations are handled on the power board, not on the RF stamp. And this is not a problem, this is a restriction using the RF stamp as standalone, because also customers using the RF stamp has to handle this in their electronic. It's absolutely necessary because we won't place a button on the RF stamp. It makes no sense. We won't place an LED on an RF stamp. It makes no sense because we have a power board for this. And on the power board are the buttons placed and the LEDs and the interfaces. Okay, and to understand how it works, it's necessary to understand the communication structure between the RF stamp and the power board. Here we have the rocker switch. The rocker switch sends out 3 subtelegrams, as I told you. You press it one time, he sends out 3 subtelegrams. A subtelegram, as I told you, consists of a preamble, a sync word, the knocking, the unique ID and the data. This is sent from the sender to the stamp. So in the first step, this is the currently implemented in our evaluation kit. The RF stamp gives all this data, exceptional the preamble and the sync, because this is only for RF. Exactly this data gives it from the stamp over the hardware interface to the RF board. Yes? Every subtelegram will be sent separate over a so-called UART interface. UART interface is only a hardware interface. So the stamp gives this data, all these subtelegrams, to the power board. And the power board has to summarize these 3 telegrams to 1, because the power board has to know I got 3 subtelegrams, but all these subtelegrams are from one sender. So the power board has to summarize this. The power board has to handle all the pairing procedure. This means when I press here the button, then a command goes from the power board through the stamp and say, hey, pairing mode. And the power board has saved the list of the paired switches, because the RF stamp is stupid. The RF stamp only gives 3 subtelegrams through the power board. So the power board has to save the paired sender list here. This is the current state. So now when the customer wants to use the RF stamp standalone, he has to implement all these intelligence on his own electronic. And this is a high effort for him. Yes? Because we can give him an interface specification, yes, where all these data are described, but he has to handle all these points, summarizing the subtelegrams, pairing procedure, and saving the list of paired switches. Not impossible. He can do it. But it's a high effort for him. So, next step. In the next step, we called it development step 1. The first samples with this development step we will get end of July. And mid of August we will get the first delivering of 200 pieces per week of development step 1. And this development step 1 has a little improvement. And the improvement is that the RF stamp now will be sent only the summarized subtelegrams to the power board. So the power board has to handle in a second step not summarizing the subtelegrams, but pairing procedure and save list of paired switches. So the first development step we now go is the intelligence of the RF stamp is we summarize these 3 subtelegrams. So the power board gets only the information switch 17 is pressed. Remember, in the first step, the power board gets the information switch 17 is pressed, switch 17 is pressed, switch 17 is pressed. And the power board has to handle, okay, these are 3 subtelegrams because the time between the telegrams is very short. It's from the same unique ID and it's the same release date. This must be 3 subtelegrams. In the next step, we summarize it on the power board, on the RF stamp, and the power board gets only one message. Switch 17 is pressed. But the power board has to save the list of paired switches. Then he can decide, is switch 17 important for me or not? And he has to handle all the pairing procedure. This would be the first development step. For this step and for the current step, on the power board, a microcontroller is necessary. Intelligence is necessary. The power board has to handle all this information. So customers using our stamp in current step or development step 1 need intelligence on their power board electronics. They need a microcontroller who does this, handle this information. So, and in the second step, development step 2, which you can see on slide 10, then it will be not necessary to put on intelligence on the power board. This customer-specific receiver could handle it only with hardware, not with microcontroller intelligence. And why? Because on this RF stamp development step, the complete pairing or the complete saving of the unique ID will be done on the microcontroller of the RF stamp. This means the RF stamp we called it phone book. It's a list of the paired senders. And the advantage is you don't need UART communication, you don't need information with subtelegrams or with unique IDs. You only need output information. Switch is pressed. The receiver hasn't know if it is switch 17. He only has to know a switch which is paired with me, send me a press, and I have to switch on the light. It does not matter if it is switch 17 or 18. It's a paired switch, and I have to switch on the light. And this is important because he don't need intelligence. He only have hardware outputs. But the pairing procedure, yes, the pairing procedure has to initiate it by the power board, because the RF stamp won't have buttons and won't have LEDs. So the power board have to say start pairing, and then the pairing will be handled on the RF stamp. And the RF stamp gives back, pairing is activated, you can switch on a LED if you want. And this means, imagine if we integrate our RF stamp, for example, in a bulb. Yes? Then the bulb needs a possibility activating the pairing. It could be a little button. Or it could be, for example, I switched off the power supply 3 times in a very short time. On, off, on, off, on, off, and then pairing is activating. Could be. But the best way could be a short button. So I press this short button on my bulb, and then my bulb sent in to the stamp, pairing mode is active. And then the RF stamp saved all the pressed switches in his phone book, and then for example, the bulb says pairing mode is off, and then he's wieder off. But the power board has to handle or initiating the pairing process. But all the unique IDs and all this is handled on the RF stamp. And this is the big advantage. The outputs are only in hardware. On the power board, no microcontroller would be necessary to handle all this RF communication. And this will be available in development step, and this development step is available in a few months because it's a high effort to integrate this phone boot functionality in the RF stamp currently. Okay, so remember, 3 steps. The current step is the RF stamp is stupid and gives all RF information direct through the power board. All the intelligence is on the power board. So for customers, would be a very high effort to integrate this functionality in the electronics. It's not impossible. If customers can do it, it would be possible. We will support the customers with an interface specification where all the communication is described. The next step will be we reduce or we summarize on the RF stamp the subtelegrams. So the engineering effort will be reduced a little bit on the power board side, but the customer has to do it. He has to make the pairing procedure. He has to save the list of paired switches. And in the second step, in the development step 2, then, okay, we can say it's a complete RF stamp standalone where all the information comes out over hardware outputs. And then it's a comfortable solution for customers. They want integrated in their electronics. But it's always an integration in electronic. Yes? An RF stamp is an electronic product for integration in another electronic product. That's important. It's not so easy as a packed receiver which has user interfaces. An RF stamp has no user interfaces. An RF stamp is an electronic. Okay, I hope it's now clearer for you how the products are working. I gave you a technical overview of the most important RF parameters. I hope that gives you an impression that RF products are complicated and not so easy to use. The next step was to give you an overview of our products. It's a very important point now because now we have products available. Now you can say to customers, yes, this product we have and you can order it. And in the last one, I give you an overview how sender and receiver are working together.